tide current calculation, practice problem overview. Let's check these out. We'll just start with practice problem 1 and we'll figure out what's going on here. So on 9 November 2023 at 3:30, you're inbound at Charleston Harbor entrance buoy 10, ACT 6611. What is the direction and velocity of the current you're encountering as you pass buoy 10? See illustration DO58NG. Here's illustration DO58NG. All of these are going to use the top one, but let's look at how we line this up. So ACT 11, see this? ACT 6611, Fort Sumter Range, buoy 10, depth unknown. This is what tells us we're on the right chart. Okay, good. And now when you look at this chart, it asks for the 9th. Let's record this stuff so we don't get confused. So we're looking at the 9th and what time on the 9th. You know, it's easy to get this 2023, this year, confused with the time, I found. But here's the time, 0330. At time, 0330. Now, what else does it give us? So it gave us this number. We lined it up here. What's the direction and velocity? It wants direction. What's that equal? And velocity. What's that equal? Okay, cool. And here's the illustration. Now, how do we go about this? Let's look at the parts of this. Here's speed on the side. Here's the date and time on the bottom. And if you look, here's the dates. These are the 9th, and the times go up. Each one of these are 3. So it's 0, 3, 6, 9, 12, 15, 18, 21, 24 goes back to 0 and starts on the 10th. So this side is the 9th. This side is the 10th. Each one of these gray dotted lines is 3 hours as we go across. And now we're on the 9th, so we know we're using this side of this graph, and we're at 3:30 a.m. Okay, so here's 0, 3, here's 3, and if we were to divide this, it'd be like 3, 4, 5. You can pretty accurately divide this. So if this is 3 and this is 4, then 3:30 is right between the two. And if we follow it up, we hit just like right up in here. You know, we're just above that dotted line, and we're pretty much between 0.2 and 0.0. So if we're between these, we're going to call it 0.1. So the velocity or the speed is 0.1. And it happens to be above. This line is basically slack water where it's 0. And we're above it, so we're in the flood. Above this line is flood, below this line is ebb. And then it always uses these directions conveniently. So mean flood direction is 280. So since we're in the flood, it's 280. And I mean, that's how we solve it. So we look here, the answers are in velocity, then direction. Our velocity was 0.1. So one of these two, 0.1, but the direction was 280. So we're finding C. And again, that 280 came because we are on the flood side of this dark dotted line that represents slack water. We're on the flood side. And the mean direction of the flood is 280. So that's what all the problems give. So we got 1 is C, 0.1 knots at 280. And you'll notice over here with the speeds, they have negative speeds, but the answers to the problems never have a negative number. So we're always just using the absolute value. So C, 0.1 knots at 280 true. That's what we got. Let's check. 1 is C. Excellent. It's going to be redundant on the first practice problem because it's the one we solved, but this one just did a little bit more in depth. What is going on with DO58NG? We'll see you on practice problem 1, tide current calculation.
If you find these videos helpful, consider using US Captain's Training as your course provider when getting your captain's license.